is really just reminding you again what p-hat is. So we had a poll. We asked 1,783 registered voters if they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate for the proportion. So point estimate for the proportion, I'm just asking you find p-hat. X over n. My x is, and n is, so this one doesn't come out real pretty. We'll leave a few decimal places. And we get this estimate. Now, does that mean I could look at this and say for certain that most people are going to favor the death penalty? No. In this particular scenario, almost 63% did, but is that going to be the same as the whole population? No. If I get a different sample, will it come out to be the same p-value? No. So this is an estimate on one particular scenario, but we know that in actuality that doesn't match the real value. So does this mean most people? No. Would a different sample give a different percentage? Absolutely. So we need to be able to say how confident we are in our estimate. I am 75% certain that it would be, would I even be able to say it was equal to 63%? Probably not, but maybe I could give a range of values. I could say I'm 75% confident it will be between 55 and 65%. Or something like that. We want to get a range of values. So that's what's called a confidence interval. So it's based off that point estimate. That point estimate is going to be the center, and then it'll be a certain amount above and below. If you ever look at, you know, we've got elections today, right? And anytime they are talking about polls and they report results, they always have a margin of error. Plus or minus 3%. That means it's within 3%. So if they said 75% of people are in favor, then it could really be anywhere between 72 and 78%. Okay, there's a window of values. That's a confidence interval. How confident you are, so 95%, 90%, 75%, that's your level of confidence. We will be talking about the Z alphas again in the scenario. Remember with the alpha, when I wrote something like Z alpha, alpha was what?
Area to the right.
Area to the right. So when we wanted to use the table, we had to do 1 minus to get the area to the left. So we will have to find these alpha levels based on whatever level of confidence we have. In general, we'll make a point S or a confidence interval following this format. So it would be our point estimate, what we estimate it to be, plus or minus some margin of error. That margin of error is just how accurate. So if I said, 3%, that's more accurate than if I said we had a 10% margin of error. Okay. If you think about it on a number line, here's our guess in the middle, or the p-hat, and a margin of error is just going to give you a window of values. So this distance from my guess, that is a margin of error. We can go both ways with it. What would happen to that window if I make if my error is going to get bigger, what's going to happen to my range of values? The bigger my error, the wider my window will be. Okay, that margin of error that we're talking about is really dependent on 3 different things. The level of confidence. As you get more confident, your error is going to shrink. Okay, if I say I'm 90% confident, then I have a certain amount of error. But if I said I'm 99% confident, that error is getting smaller because I'm more confident in my answer. Sample size, we know in general, the larger the sample, the better the data. So the bigger our sample will make our error get smaller. And also standard deviation. Standard deviation tells us how spread out the values are. So if you have a really high standard deviation, your values are very spread out, that's going to be a high level of error. If all my points are really close to each other, we're pretty consistent, that's going to be a smaller margin of error. Any questions so far? Okay, so I'm going to cover the next 2 slides and I'm going to stop. I'm not going to work out an example today. I just want to review a few things. So anytime I'm talking about p-hat, we have the same things we talked about before the quiz. We have to meet our criteria. The n times p times 1 minus p has to be greater than or equal to 10. My sample has to be less than 5% of the total population. We still have the mean is equal to p. The standard deviation is the square root of p times 1 minus p over n. So all of that is still true when I'm looking at my p-hats. And then we are going to build a confidence interval from this. So the confidence interval, these are formulas that are on your formula sheet. So under chapter 9, it's the first bullet here. I broke mine out into a lower and an upper. When you're looking on your formula sheet, it just says p-hat plus and minus. So p-hat is your center. You have to subtract something to get your lowest point and add something to get your highest point. So we'll take whatever our point estimate is, z alpha over 2, which we will talk more about tomorrow. That has to do with our margin of error, which I'm going to give you your margin of error. You're not going to have to calculate it or anything. I'll say, give me a 99% confidence interval, or give me a 90% confidence interval. So you'll be told that. And then the rest of the stuff we already have. We'll have the point estimate, 1 minus point estimate, n. So really, it's all the same numbers that you've been using, it's just a different calculation with them. And we'll get a confidence interval from there. Couple things. The meaning of this, so we'll be able to say we are whatever % confident the true value is between whatever the lower bound is and the upper bound. So you'll be able to say I'm 90% confident the true value is between 80 and 85 or something like that. That margin of error is the thing that we are adding or subtracting. So that is the z alpha over 2 p-hat 1 minus p-hat over n. So that is how we will get the actual error level.